Dear students, in this second lecture of this course, I am going to discuss the concepts which are required for understanding CAD CAM. Let us first discuss how people communicate design or what is design communication. There are variety of things that come to in our mind, primarily three which come to my mind. One is image or the picture. You design something, you take a picture of it, maybe it is a sketch or something, you take its image and communicate. The second thing which comes into my mind is the engineering drawing. You all have gone through engineering graphics course in your first year, and as you are aware that with the help of some line types and all that, you create something which is can be understood by the person who is well aware of or well conversant with the drawing language. Okay, so that is the another way of design communication. And the third thing which comes into my mind is the CAD model or the geometric model. You all have used one or the other CAD modeling software in your previous courses. So I will ask you some questions. So what can you do with each one of them? Which in each one of the image, engineering drawing or CAD model? So let me ask you, can you find dimensions with any of these three methods? Can you make a physical part or reproduce a part by seeing information from these three methods? Can you share the information electronically, or can you edit make can you edit the information or manipulate the views? For example, you are having some picture, can you have a different perspective of the object or the product, or by rotating it, zooming it, changing color, etc.? Can you see that? Or use can you use that information for downstream applications such as manufacturing inspection, etc.? So you keep your answers with you, and we'll be discussing in the next few slides with respect to these questions. So let us see this picture and an engineering drawing which is being shown in this slide. Uh, the picture is basically which is you are seeing something in a particular view. You are not able to identify what are the extent of dimensions. For example, I give you picture of a person, you will not be able to identify the height, the weight, the volume, etc. possessed by that person. On the other hand, the the engineering drawing, with the help of engineering drawing, because it is the information is displayed in a particular syntax, it is available to you, like dimensions are there, like you have different views of it to understand its three dimensionality. Okay, so you have a lot of information to understand what is the total volume, what is the basic dimensions of this part, each and every feature is dimensioned, all that. And there are different forms of picture or engineering drawing. You have either the hard copy form of these, or you have the electronic form. So you can do a lot of communication with these, but the picture is having a limited capability, although it may provide you a very scenic view, a subjective view of the information, but not as objective view as is given in the engineering drawing, which can be measured. So a picture represents a view of an object without any explicit information about its dimensions. An engineering drawing is a representation of an object to describe its features along with their dimensions and required properties. Now coming on to the another comparison, which is engineering drawing versus CAD model. Now, as you are all aware of, engineering drawing needs a qualified person to understand its description, but it has its inherent good qualities also. That engineering drawing is very simple to handle. You can always hold it in hand with in a paper form. You can interact with people with having different languages. For example, you want to share the information with somebody sitting in China. So engineering drawing information can very well be understood across boundaries, across the linguistic boundaries. Okay. And for a manufacturing a part from a drawing, the person needs to understand its dimensions. So that is the prerequisite. If you want to understand something from a drawing, you should be able to, you should be able enough or qualified to understand that information given in the drawing. And once that information is available, you can use that information for manufacturing related information. For example, a hole in a drawing may mean drilling in the manufacturing. Okay, so sometimes I also correlate this engineering drawing with a sign language. A sign language doesn't have any barriers of language itself. The sign language is same whether you go to Japan, China, or US, or Europe, or any other country. So here is an example of an engineering drawing. So you can see that all the information, like for example, this has five parts. Basically, the quantity of each part is given, the names are given, and this is the first part, which is the top plate. It has two views of it are given, and you by seeing these two views you can reproduce the part. You can find out what kind of job or stock you need to machine this, what kind of holes you need, and what are the other features which can be seen or which can be understood with the help of these two views, that is the top view and the front view, or top view and the or plan and the elevation. Okay, so similarly, the other parts can also be very well understood. On the top of that, the engineering drawing has information about the tolerances, the fitting aspects, etc. of this assembly, which is the five parts are going to be assembled ultimately. So all that information is given in the engineering drawing for a person to understand and conceptualize or make a three-dimensional image in the mind, so that that information is reproducible, is objective, is having all measurement and other required information. CAD model, on the other hand, is another way of representing the design. The difference being that the engineering drawing needs a person to interpret the information, and the CAD model, the information is evident. You can rotate this, you can manipulate this, zoom this to find out the difference. You can have a sectional view, cut section this with the help of a CAD software. You can rotate this assembly with the help of a CAD software to see its different parts, how they are engaging in all that. And this is the basically the difference between CAD model and the engineering drawing. But I would like to stress here that despite the fact that you have multiple CAD modeling software, multiple CAD-CAM software for you to help you to understand the design and all that, engineering drawing is the most basic thing still being used in the industry for record keeping as well as for communication alongside CAD models or CAD CAM systems, which we are seeing a lot of these are being applied in the industry. But I will say that engineering drawing is still very useful. This is a very simple way of cost effective way of representing your designs. So What is the difference between the early CAD system that evolved? We have seen in our previous lecture that it evolved in 1963 with the evolution of or development of Sutherland's Sketchpad, and over the time they developed slowly with the evolvement, with the evolution of more technology, both hardware as well as software. Early CAD systems, they were basically automated drafting board systems. They were just systems to record your drawing, for example line, circle, etc. They were useful for displaying and storing 2D part information, for example information contained in an engineering drawing. Interpretation of the drawing was left to the user. You could make a soft copy of the drawing, you can print it, but in the end you need some a qualified person to understand that information. However, recent CAD systems, they are capable to define objects in three dimensions, as we have seen with the help of this example, and you can do even much more that we will be discussing in the duration of this course. Let us see what you can do with the help of these CAD/CAM tools which are available these days. For example, you can have the computer aided assembly. Computers can be used to build assembled models or assembly models of products by defining mating relationships. You can use systems to design and redesign products for ease of assembly. We also call sometimes this as design for assembly, or they can be used to evaluate designs and redesign products for ease of disassembly. Assembly as well as disassembly both are very important for any product to be designed. You design a two-wheeler or a bike or a motorcycle, which is very good, very nice. It is aesthetically very good. It gives you a wonderful mileage and all that. But for maintaining it, for example, you got a flat tire, you have to do a lot of effort. You need, say, two people at least to replace your tire. That becomes a basically a very big disadvantage for such kind of a vehicle. Or you put something air conditioner in a big building, multi-story building, at a place where it is not at all maintainable. Okay, so all these things, like assembly of product or disassembly of product, are both important. You need to disassemble some engine from a car. You need to have a look at how the engine is going to be disassembled from the main chassis for ready for good acceptability of the product in the market. Computer aided analysis tools are, they are used for routine and final design checks. For example, you are seeing this spanner. With the help of computer aided analysis tools, you can apply the conditions under which it is going to work, and with the help of simulation you can find out that there are some areas where the stresses are going to be very high, and which is being the exact value is being given here with the help of this color scheme. And the areas where it is going to be high stress becomes candidates for reinforcing more material over here, and the material could be removed from areas where the stress is low. So this kind of analysis is normally done in the industry with the help of computer aided analysis tools. There are a variety of computer aided analysis tools available. For example, ANSYS is one, or Simulia is one, and NX Nastran is one. So all these tools, they are basically used for computer aided analysis. Computer aided optimization is also used for arriving at optimum design of any product. Whenever there are many feasible alternatives, you can always find one which is optimal. And computer aided optimization is used you can do two kinds of things, either parametric optimization and shape and size optimization. Size, you can see to figure out what is the size optimization. Basically, suppose you have this product, you are free to change its width basically. Then it is called as a size optimization. You are free to change the size uh, depending upon the condition that the functional requirements are met. For example, it is going to be loaded with something, so it should not bear bend too much, etc. And up to that extent, you can reduce the thickness. Then shape optimization is you can along with changing the dimensions, you have the freedom to remove material from somewhere over here, you know. So that kind of thing can be the called as the shape optimization. And topology optimization is uh, you can change even the topology. Topology here means the relationship between these lines. You can either have a rectangular, or you can even have this thing zigzag. So that becomes a topology optimization. So all these terminologies are just preliminary for you. You can always find out more details if you are interested to. And on this adjoining figure, you will see that this is the initial design for this part, and it was subjected to computer aided optimization tools, and this is the result of the after it was subjected to computer aided optimization, the optimal design. So whenever you are doing this kind of optimization, you can always provide certain constraints. For example, your constraint may be the whole diameter should not change, or this diameter should remain the same, because these are going to be fit with some other part which have already been finalized. So, or the distance between this and this end of this fork should not change. In this case, it is changing, but you can always provide these kind of conditions. And rapid prototyping is another latest development, recent development that is very well being used for manufacturing different parts. And rapid prototyping machines, they can be used to build physical prototypes directly from the CAD models, or nowadays they are using it for making the parts, or manufacturing for supply of these parts to the customers directly. Okay, so this is you can refer to more details on, you can watch some kind of video to understand this process. But at this point of time, I would like to only say that rapid prototyping, computer aided design is the only input, or the CAD model of the part which you are going to make is the only input required for making this part in rapid prototyping machine or 3D printer. Design for manufacture. This is another aspect which has been made possible with the help of CAD tools, with the help of the product design of this part. You can simulate the conditions under which it is going to be filled with, say, molten metal in a mold, in a metal mold. And you come to identify that there are some areas where the while filling the metal, this may incur with some kind of problems. So this sort of information can very well be gathered beforehand, before you actually make the die for this part, which is a very costly affair. So making a die which is defective is very costly affair, because typically it may cost you thousands of dollars, or in rupees, if I call say 4 or 5 lakh rupees for a simple die. Okay, so that is why simulating such kind of scenarios beforehand in the computers is recommended for all to visualize what kind of problem can occur in the manufacturing stage, so that they can be avoided. Thank you.